I wanted to focus on how to solve trigonometric integrals. In this video, I'm just be focusing on sine and cosine, but in other videos, I'll do secant and tangent and cotangent and cosecant as well. All right, so let's start off. So in order to do trig integrals of sine and cosine, you need to know these three formulas. Um, so you use these formulas when you're given the first one when you're given odd exponents, and you use these two formulas when you're given even exponents. Um, in these examples, I'll be going back to the formulas when to use it, so you'll understand it right now. If you don't understand what I'm talking about right now, you'll understand as the video goes on. So let's start with example one. All right, so what is the indefinite integral of cosine cubed x dx? So what's the first thing we want to do? The first thing we want to do when we're given this type of uh, problem, let's see what we're going to do. So we have an odd exponent, so most likely we're going to use the formula of this. So let's try to make it into cosine squared x. How do we do it? Simple. We just break it apart. Now we have cosine squared x, and we have cosine x. What are we going to do? We are going to use the formula and change cosine squared x to what? 1 minus sine squared x. Now we have 1 minus squared x. What are we going to do now? At this point, it's probably best to think of as a u substitution. So if I make my u cosine x, I can't get rid of sine squared x. But if I make my u sine squared x, or just sine x, I can get rid of my cosine x. So at this point, it's probably best to make u sine squared x. So that's what I do. I make u equal to sine x. Du is equal to cosine x dx, and dx is equal to du over cosine x. I input my information. So now the question looks like the integral of 1 minus u squared times cosine x times du cosine x. So as you can see, cosine x will cancel out, leaving us with 1 minus u squared. So what are we going to do? Simply is integrate. When we integrate, we're going to have u minus u cubed divided by 3 plus c. And to finish out the problem, we just simply plug in our u, which was sine x. So the answer is sine x minus sine cubed x divided by 3 plus c. So the indefinite integral of cosine cubed x dx is sine x minus sine cubed x divided by 3 plus c. And that's how you would approach a problem as such. Now let's go to example 2. All right, so now the example is what is the indefinite integral of sine to the fifth x times cosine squared x dx? So what are we going to do? I chose to break apart sine x because it's easier to make u equal to cosine, because we can do now is change sine to the fourth to sine squared x squared, and then what we can do now is change sine squared x to this 1 minus cosine squared x. And now, like I did before, see, this is why I broke up sine to the fifth. I think it's usually best to break up the bigger exponent. That's what I personally do, and it works for me. I don't know if that's some type of rule, but that's what I've done, and it worked for me. So basically, now we have 1 minus cosine squared x squared times sine x times cosine squared x dx. Now what we're going to do is now pick our u. So it makes sense to make our u cosine, because if we make our u sine, we're not going to cancel anything out. If we make our u cosine, we can cancel sine x out. So we make our u cosine x, and we get du is equal to negative sine x, dx is equal to du divided by minus sine x. So now we input information, and we move the negative du over sine x to the front, negative sign, and we input our u variables. So it's 1 minus u squared times sine x times u squared times du sine x. As you can see, I've got the x over here, but we cancel sine x out, and now we're left with, we cancel sine x out, and we also FOIL this to make it more simpler, and we're left with 1 minus 2u squared plus u to the fourth times u squared. And to make it even more simpler, we distribute the u squared, and we're left with u squared minus 2u to the fourth plus u sixth du. And what we're going to do now is simply integrate. And if we integrate and we distribute the negative sign, we're left with negative u to the third divided by 3 plus 2u to the fifth divided by 5 minus u to the seventh divided by 7 plus c. And to finish it off, we just want to substitute whatever u was, and in our case u was cosine, so the final answer is going to be the indefinite integral of sine to the fifth x times cosine squared x dx is equal to negative cosine third x divided by 3 times 2 to the fifth cosine fifth x minus cosine to the 7 x divided by 7 plus c.